This is the story about DevOps, MLOps, and Triceratops. And the reason why I've called it this kind of head title is that I've spoken to some people in analytics. I kind of come from the world of DevOps, and I've seen that not everybody knows what DevOps is, and let alone MLOps. And kind of some people said that it kind of resembles Triceratops. So this is my take on trying to tell you the tale of MLOps. Of what is it anyway, and why is it necessary? So the content today is how development and operations became DevOps, and also the problem with how to merge the ML code into the existing infrastructure that already exists. And also MLOps, how to get there. And as I said, this is sort of a cartoonish presentation, so I will tell you the tale of how MLOps actually came. So before that, this is a true Redpill Linpro story. That's where I work. I work as a sales specialist in analytics and cloud. I sort of have one leg in the machine learning world and one leg in the DevOps world. DevOps is the core competence of Redpill Linpro. And we started quickly to understand that ML practitioners don't really have the same benefits as software developers as they do in the DevOps. So how to solve this? Redpill Linpro is the largest open source service provider in the Nordics. So I will tell you a little bit about this, and I will also use open source products to tell you about it. Other than that, we do integration, cloud services, and also analytics architecture. So let's start. Once upon a time, there was development and operations. Now, development sat in one department on one side, and he was writing software code. And operations sat on the hill on the other department, and he was deploying code to production. And he was also minding his own servers and his security. So once development had written some code, he threw it over to operations for him to deploy. However, and this is a true story, often than not, this just did not work. And operations could just not figure out why. So development sat on one side saying that, you know what, this actually works fine on my computer. It has to be your fault. And then operations on his side said that, well, everything works fine here except your code. So what is the problem? So development would say that, can't you just replicate my environment on the server? Whereas, well, operations had so many other things going on there, so you can't just replicate it because then everything else won't work. And this was a big problem because they kept bickering between them, and it was sort of a bit of a fight. So let's just, for the sake of it, call it that the Lord of Agility. At this time, there was a lot of talk about lean and a lot of talk about agility, not in sort of software development, but in other parts. Developers, it was actually an initiative from the developers, and they figured out that why can't we just use the continuous feedback loop, just like, you know, everyone else is trying to do. So what exactly is the continuous feedback loop? The key supporting principles in this and in Agile, basically, is to break down work into smaller tasks and also create milestones. So take that big kind of mastodon and try to like break it up into little smaller pieces. A key supporting principle as well is collaboration. You have to collaborate. You also have to have versioning. And how do you get that? Well, you get it from Git repos. So Git repos is important. But the most important thing and the key enabler in this feedback loop is continuous integration and deployment, also called CI/CD. So a CI/CD pipeline is continuous integration and continuous deployment. It means that you can automate from Git, just do a Git commit and a Git push, and you can have self-service and put your code to production. So automated deployment of code to production. And the key part here is this little sentence that you see below, which is in principle CI/CD, which is build, test, and deploy. So the first stage is Git, and I'm sure everyone here has a bit of knowledge about Git, either from GitHub or GitLab or Bitbucket or some sort of Git repo. So a Git area is where you commit. It's where you commit your code and you merge it to the new code to the code base. The build session is where you create a runnable instance for the software. And in many instances now, it's usually about containers. You can also do it to a VM, but there's a lot of benefits with doing this in containers. I'm not going to go too much into that. However, when you build, you take your code, you pack it into all your kind of dependencies, your libraries, everything that it has to take to run it. And this, of course, is all put into Git. So when you build it from Git, and then you test it. You test your code. You validate the correctness of it. And by that, I mean you can test the semantics of it. You can also do unit code testing. Does the sort of function work? Is it logic? And if it goes through, you can see that you commit it, you build it, check, and then you test it, and it checks out. And then if everything in this automated pipeline checks out, it is deployed to production. So basically, this is CI/CD. And by doing this, you have a developer that can sit on one side, on the left side here, where you can build yourself, test it, and then release it or deploy it. And the ops part just sees through it that you have the necessary infrastructure, like a container platform with the Kubernetes cluster. And they operate it, monitor it, and they plan, and then it goes back. So, of course, you sit there and you have a chat with the customer, or you can see that something is wrong. Then you figure out, you know what, I have to build some new code or new feature or something to repair this or to make it better. And then you do that for yourself. You sit on your laptop and you test it, and then you release it and you deploy it yourself, and you see that it actually works. If not, you can roll back and just release the last functioning version. So this is in basic what you get. It's kind of an assembly line where you have development on one side. He's creating code and he's putting it in and is testing it, and it checks out and off it goes into production. So back to development and operations, they now became friends because now they're actually working in the same team, and they even put development basically in the same department as development, so you can have a bit more collaboration. So hence, here you have DevOps. Development and operations. Now, DevOps was a movement, and I'm pretty sure everybody has heard the name, and it's grown in popularity, and it kind of was a hard take in the start. But as soon as everyone started working in the cloud, it became more and increasingly more popular. So here you have DevOps working around with the good book of DevOps, trying to mission his statements there. And flying around the world trying to make this development and operations a better place. However, then you have the planet ML. Now, the planet ML is not really a part of it. It kind of looks down on Earth and see that, well, you know what, we're not into these DevOps things. And on the planet ML, you have the Queen ML. And the planet ML is a weird and sort of magical world for people on Earth. It's where all the kind of weird sorcery happens. And not many people on Earth actually understand what machine learning and what we do on this planet. So how do we actually, what is the problem here? So ML code is not very easy to put into this traditional CI/CD pipeline. So you can't just, go into and put it on the same assembly line as a development has done here, because it actually won't work. So it's kind of like you have two different planets speaking two different languages. So what you need here is MLOps. Now, MLOps is CI/CD for machine learning. And as I said, this is not without problems. Because the problem is that ML code is not software code. It is code, but it's also statistical code. Therefore, if you try to put this in a traditional CI/CD line, you will get the kind of semantics and the unit code tests, they will actually pass, especially if it's written correctly, but they will not actually tell you if the code or if the model is predicting right. It doesn't say anything about that. In addition, you have quality that also relies on input data. There's a massive amount of, if there's not really good data in, then there's a not very good model coming out. And also, as I'm sure you all know, ML practitioners don't really work with one stack of services as software developers do. You have different libraries, you have different tools, and you have different algorithms, and you also test them usually within trying to make one model. So how do you actually fit this into the traditional CI/CD? The goal here is to have self-service deployment of models to have versioning and collaboration as you do with the software development. And also, of course, automation. And this is the traditional one, as I showed you, the build, test, deploy. To make this into a MLOps or MLOps pipeline, you have to have another step. You have to have build, test, and validate, and then deployment. So what is this validate? The validation step is that you predefine the prediction acceptance area. It's basically, if you're doing this from scratch, I'm going to show you a little bit about that afterwards, how to do this. But if you're doing this from scratch, then you actually have to hard code sort of in a YAML file, what is this predefined prediction acceptance area? That could be, for example, if the model predicts less than 96%, then it's not accepted. Over that, then it's accepted. It could be like an accepted score area, that within this area or within these numbers or range of numbers, the model is actually validated. It's okay. So I know that you validate within your, when you test your model in, for example, Jupyter, but the thing is there are numerous amounts of very good benefits by doing this in this in CI/CD step. And I will show you how. Let's say that you have, just for the sake of it, you're using GitHub. You push your code. You're doing a code commit and a code push. Git push. You build a container. This is done automatically. All you have to do is press git commit and git push, and it automatically builds a container with your model with all the libraries, sort of dependencies and everything in it. Then you do the test, the normal test with the unit code testing and the semantics testing. And then you do the validation test. Is this model actually within the range? If it is automatically deployed. Now, the great benefit about this is not necessarily the first time you do it, because this is sort of an iterating process. So if you want to, you can set a timed frequency where you can, for example, automatically put your code, your model code within this CI/CD process and check and validate if it's still within range. You can also, for example, set it off if you have a new load of batch data coming in every night. You can automatically push it so that it tests and validates that the model is still within range on the new sets of data. You can also do this manually, of course. And the good thing about this is that when you do this and the validation fails, you will be told. You get an email saying that your model is now outside of range. And then you can retrain it and you can test it, and it actually deploys automatically. So in this way, you get actually self-control over or self-service of your model in production. And also, if you see that the model is not working, you can just roll back to the last version that was working and try training again. Another key part about this is what software developers called A/B testing, because you can also, if you're doing, for example, if you own a net shop, and you see that, okay, it's a bookshop, let's say it's Amazon, people who bought this book, they also bought this book. So if you're doing a prediction model and you have two different models and you want to test it, or you just want to test it from the one that is in production, then you can go and test the new model for a small subset, or like a user base, a small subset of all the users, let's say 10% or 20%. And if the model is actually, people in this test area, they buy more books than in the other one, then you can say, well, it's success. So I actually want to bring this new model into the rest one. So you can try to test it a lot more on real-time data. So this is a little story about how MLOps came. And now you have machine learning practitioners that can also use the exact same assembly line that the developers can, check it, and automatically put to production. So they all lived happily, agile forever after. That was the end of the little story. I promised you that I would tell you a little bit about, just checking for the time here, that I would tell you a bit about the different kind of services that you can use. And we've built this from scratch, and we've also used other sort of platforms. So building from scratch takes that you know a bit of development. Either you get someone to do it, someone like we can do it, or someone else in your development department. You can use, for example, in GitHub, you have GitHub Actions, which is a CI/CD pipeline that you can use. GitLab has another called just CI/CD plainly. If you don't want to use any of these, or you, for example, use Bitbucket, then you can use Jenkins to sort of set this pipeline up. It's useful to have sort of a container platform ready-made. We have one already, then you're sure you can find it. I know you can find it in AWS, you can find it in Azure as well. We, for example, have a Redpill Linpro Nordic Cloud, which is a OpenShift container platform. And you just get a user, and you can just check in your code within a container, and it runs on the platform. That's kind of the hard build. You have other services that you can use as well, like Kubeflow and MLflow. Kubeflow, however, it's necessary that you have a Kubernetes cluster lying without. So if you don't have that, then Kubeflow is a little difficult to use. MLflow comes from, Databricks uses MLflow, so MLflow is quite good. And you will, of course, have platforms. I actually tipped you on a little webinar that we did, and it's actually on YouTube that you can see, where one of our solutions architects built this pipeline on AWS using SageMaker and Code Pipeline. And it's a little bit easier because all the tools are there instead of kind of building your own from scratch. And then there's, of course, Databricks. It's also a very good kind of unified platform building on open source products. So yeah, that was actually it for me. This is my contact info. My name is Mia Ryan, as I said. If you have any questions, then please just feel free to send me an email or just contact me on LinkedIn. And yeah, I think that was it from me.